Welcome back, guys, to this class where we are still looking at factor theorem. So under this example, we'll be looking at a polynomial of which we are looking at a particular divisor which we are supposed to prove that is not a factor of that original polynomial. Now in this question we have, if h of x equals x cubed minus 3x squared plus 6x minus 40, show that x minus 5 is not a factor of h of x. So what we're supposed to do here is actually, first off, take out your polynomial h of x. You have h of x equals to this, x cubed minus 3x squared plus 6x minus 40. This is the polynomial. But then we want to show that, so to show that x minus 5 is not a factor of h of x. So that is what we want to show now. So to show that, we use factor theorem rather. So from factor theorem, we equate our x minus 5 to 0, and upon the equation, we have x equals to 5. We've gotten a value for our x. Since we've gotten a value for x, the next thing we do is to substitute the value of x, and substitute x equals to 5 into f of x. So I know that, h of x. Since I know my x now is 5, because from factor theorem, I can now say h of x will now be what? I'll have 5 cubed plus 6 times 5 minus 40. Here I have 5 cubed is 125 plus 30 minus 40. 125 plus 30 minus 40, that gives us 115. Now 115 is not equal to 0. Recall that for x minus 5 to be a factor of polynomial f of x, then h of x must be equal to 0. So since h of x is equal to 115, which is not equal to 0, then x minus 5 is not a factor of h of x. Proven. So we are done with this question now. We have made this analysis of proving that since h of x is not equal to 0, that means when we use factor theorem and we equate whatever our divisor is to 0, and then we insert it into the original polynomial, we are expected to have 0 as the value of our polynomial. But once the value of our polynomial is not 0 and it's giving us another value, it just implies that the divisor is not a factor of the original polynomial. So it is proven in this case. In the next class, we'll look at another example on how we can actually apply the factor theorem to solve questions also. See you next class.